Alright, so welcome again, guys. In this video, I'm going to be explaining to you how to calculate the oxidation state of a species or the oxidation number of a species following the general rules. You should be doing this probably at your preliminary level of chemistry, of course. So first things first, your oxidation number or your oxidation state, I would say, is the apparent number of electrons gained or lost by a species. And the word apparent is used simply because it might seem like the species has gained or lost these electrons, but it's not necessarily so, based on the number of electrons lost. And when we do the examples, you'll see it, that the number of electrons lost or gained is not something you'd have been accustomed to. You're accustomed to species losing and gaining 1 or 2, maybe 3 electrons, but not the numbers that you'll be seeing. And that's why we say it's the apparent number of electrons gained or lost by a species. Now there are rules governing calculating your oxidation state. Right, so there are rules governing calculating the oxidation state. The species that you're going to encounter are going to be either charged or not charged. If they're not charged, their charge is 0, of course. So we're going to look at the species which are, well, not first or last, but we're just going to work them interchangeably or alternatively, rather. So here's the rule. If the species is charged, the sum is not charged, if the species is not charged, the sum of the oxidation numbers is equal to 0. So let's look at that now. All right. Well, so we're looking at if the species is not charged. So the sum of the oxidation numbers is equal to 0. Let's take something like, let's just say SO3. For example, SO3, sulfur trioxide. So sulfur trioxide has no charge, clearly, because if it had a charge, you would see somewhere to the top right up here a number with a charge, a minus or a plus or something like that. So it has no charge. Okay. Now, generally speaking, you will not be asked to calculate the oxidation state of oxygen because generally the oxidation state of oxygen is 0. Sorry, it's -2. The oxidation state of oxygen is generally -2, except in the case of peroxides and superoxides, which we're not going to really look at in this video. Okay? But you can find their oxidation states online quite easily. So oxygen is generally -2. So we're going to have to be finding the oxidation state of sulfur here. Now, since the sum, which is the addition of the oxidation states, is equal to 0, then that's easy to find. Remember, oxygen is always -2, so I can put that right there. Then you ask yourself the question, how many oxygens are there? There are 3 oxygens. There it is. So you put a 3 there. And then it's the sum. So the oxidation number of oxygen plus the oxidation number of sulfur is equal to 0. Okay? So now this has now become a simple algebraic expression and you can solve for S. So S plus -6, because 3 times -2 is -6, is equal to 0. The rules of math says that plus times minus is minus. So S minus 6 is equal to 0. S is equal to plus 6. Okay, and as you can see there, I put the charge in front of the number because when writing the oxidation number, the charge comes first. Okay, let's look at another example involving sulfur. SO2, sulfur dioxide. Again, we will not be finding oxygen because oxygen is always -2. So we'll be finding sulfur. You ask yourself, is this species charged? No, it's not. It's not charged. So therefore, the sum of the oxidation numbers is equal to 0. All right. Then now, what do? Oxygen is -2. How many oxygens are there? There are 2 oxygens plus sulfur. All right. So S plus -4 is equal to 0. And then S minus 4 is equal to 0. S is equal to plus 4. So as you can see, sulfur in these 2 different species has a different oxidation state. So it can't be necessarily the number of electrons gained or lost by sulfur, It must be the apparent number of electrons gained or lost by sulfur. Let's look at another sulfur example. In this case, we're looking at the sulfate ion. Great. All right. Now, is this species charged? Yes, it is charged. There's the charge right there, 2 minus. Okay. And notice that with the charge comes before the number. But with the oxidation number, the number comes after the charge. All right. So again, we're going to find the oxidation number of sulfur. All right. So since it is charged, the sum of the oxidation numbers is equal to the charge on the species. What's the charge of the species? Minus 2. So when I add up the oxidation number of oxygen to sulfur, I should get minus 2. Oxygen is always minus 2. How many oxygens are there? There are 4 oxygens. Let me write that 2 a little bit better so it doesn't look weird. Okay. Then I'm going to add that now to S. There you go. Okay. So S plus minus 8 is equal to minus 2. S minus 8 is equal to minus 2. S is equal to minus 2 plus 8, because now you carry the 8 on the other side of the equal sign. The rules of math say if I take a minus and I carry it across the equal sign, it becomes plus. So S is equal to minus 2 plus 8. S is equal to plus 6. There you go. So there you have sulfur, 3 different species, and the oxidation number changes. Not necessarily among all the species, but within 2 of them, right? So the oxidation number of sulfur can be varied. All right, and that's why we say the apparent number of electrons gained or lost by a species. Okay, so I hope you found this helpful. I've only used one example of a charged species, but I will do another one just to cement the process. Okay, so here I will take another piece of paper here. Get that? No, very good. See, live your life by a compass, not a clock. Okay, so let's take another species, MnO4 minus. There you go. So this species is charged, and once you see the minus, it actually means minus 1, or 1 minus rather. Okay, right? So, but most times the 1 is not placed there, because if 1 is there, then 1 is there. So since this species is charged, the sum of the oxidation numbers is equal to the charge on the species. Okay, we will be finding manganese. Why are we finding manganese? Because we're not going to ask you to find oxygen. Oxygen is always minus 2. Okay, so oxygen is minus 2. How many oxygens are there? There are 4 oxygens. There it is right there. Okay, and so plus Mn. Okay, and now this becomes very simple. Mn plus minus 8 is equal to minus 1. Remember the rules of math. Plus times a minus is a minus. So Mn minus 8 is equal to minus 1. Mn is equal to minus 1 plus 8. But remember, when you take a negative and you carry it across the equal sign, it becomes positive. So minus 1 plus 8 is equal to plus 7. So therefore, the oxidation number of the manganese is plus 7. So there you have it, folks. Your oxidation number of sulfur, the oxidation number of manganese. Let me just fix it so you can see it a little bit better. Hopefully you can see it. Yes, there you go. Right? Not charged. Not charged. Sum of the oxidation numbers is equal to 0. Charged. Charged. The sum of the oxidation numbers is equal to the charge. You write an algebraic expression. You work out the oxidation state of the species. I hope you have found this video helpful. Remember to like and share it with your friends so that they can be helped as well with their chemistry, calculating their oxidation states. All the best in your studies, and I'll see you next time.